Well, hello guys. Sekarang itu I know. Yabla. And how are you? Let's learn SQL. I'm going to learn from here. Oh no. And this 420.
For inserting
From this view. Wait, let me do something. Inception. Here, no, so you guys can see. Like anyone will be. Oh yeah. Yeah. You won't see that. Hopefully you can see that, right? Hopefully it's really. Comfortable? Yeah, somewhat. Make it bigger. I see you do this one. Yeah. I'm gonna put it there. Yeah, interesting. There you go. Perfect size. Alright. Continue. Here. Oh, actually, I'll thin.
base management systems, your first step is always to create tables. So before we can start inserting any information, before we can start, store, and then I want to type in the name of the table that I want to create. So what we're going to do is we're going to actually create a database table. So I actually have a database table set up over here. You'll see it's a student table, and it's storing just a list of students, like maybe in a college or university. So there's three things that we're storing about this student: the student's ID, the student's name, and the student's major. So we're storing all of this information about this student. So what I can do now is I can actually create this exact table inside of my database. So I can say create table, we'll call it student, and you'll notice that I made this lowercase. So this isn't an SQL reserved word, so I'm not going to make it uppercase. And then what I can do is I can just make an open and close parentheses and a semicolon. Now, any command that you write in SQL is always going to end with a semicolon. And if you're just starting out, you might forget to put that semicolon in there, but you want to make sure that you always put it in there. Otherwise, it's not valid SQL. So I'm just going to click enter, and then I'm going to go down here in between these parentheses. And what I'm going to do is I'm going to...
Is it a good... What is it called? Good habit to
start defining the different columns or the different attributes on this table. Say primary key, just like that. And what that's going to do is it's going to tell MySQL that this is going to be the primary key for the table. Next thing we want to store is the student's name. So I'm just going to say name, and the name is actually going to be a string. So this could be like Jack or Tommy or Kara, right? It's a name that we're storing about this table. So over here, I'm going to make this a varchar, and then I'm going to make an open and close parentheses. Now remember, with the varchar data type, we have to tell MySQL how many characters we want this to be able to store. So with someone's name, what you want to do is you basically just want to think like, how many characters do we really want to allocate to storing someone's name? Because here's the thing, if I allocated like 1,000 characters for someone's name, well, in reality, normal people don't have a name with 1,000 characters, right? I mean, maybe your name would be 20 characters or 30 if you're really pushing it, but 1,000 is just totally out of the bounds of reality. And you have to think, if you're storing like millions of names potentially, you know, allocating 1,000 characters to each name.
I don't understand the skill. I think it's this setup. Oh my god. It's the same fucking shit. Yeah. Yeah, exactly. This is my problem. I see hmm. Connection nice. I've done this. Hmm. It's good. But it is cool. What the fuck is this weird? 2306. No, it's 3006. So it's this. That's lowercase. That's lowercase. Root. Oh no. That is not a name. Hmm. Mm, 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 mm. What is this? Oh, that's Mm. Yeah, let's spin this up. Mm. That's right. The password's right. Everything's fine. Yes. Oh, that's good. Okay, start. If I did something wrong. How does one delete? There it is. The capital. Oh, I need to delete it. Okay. What the fuck? Oh, it's in here. Oh, oh, it's just opening the fucking. Okay.
When
Yeah.
you only need 20 is going to take up a lot of extra space in your database. So I think what we should do is maybe say like 20. So let's say that the maximum length of someone's name we want to store is going to be 20 characters. And really, depending on the domain of the application that you're building, that's going to be different. But in my case, let's just say it's 20. And then finally, we wanted to store the student's major. So I can say over here, major, and this is also going to be a varchar. So why don't we also allocate 20 to the tree? It's really cool. We're here and click create table. We already have our table created. So we're here on this. It's quick varchar. So we have that it got cut and a semicolon.
Wait. Okay. Control enter. Ah, yes. Yeah. Oh wait, doing it. It's not showing an error. Okay. Continue.
And now I'm going to click on here and I'll click run. And what this is going to do is it's going to drop that table. So now if I came up here and I clicked on describe student, in other words, I'm saying that I want to execute this command, and I clicked run, you'll see that it says no such table, right? Table draft.student doesn't exist because, remember, we just dropped it. So what we can do is we can actually create it again. So I'm going to click on this create table query and I'll click run, and that'll go ahead and create it. So now if we click describe student, you'll see we get the table back because we created it again. So you can drop the table. You could also modify the table. So let's say that after the table was created, you wanted to give it another column. What I could do is I could add another column. So I could say alter table and then say student because that's the name of the table. And then I can say add. So what this is going to do is it's going to add an extra column onto the table. So why don't we add a column for GPA? So we could store a student's GPA, and that's going to be a decimal. So I'm just going to click a semicolon, and this is going to go ahead and end off this command. Now with decimal, remember I showed you that you could put numbers after here like 1 and 2. So what we're going to do is generally a GPA would be like 3 point something something or 4 point something something. So we're going to have this be 3 total digits with 2 of the digits occurring after the decimal point. So now I can go ahead and run this command, and you'll see it says success down here. So if we were to describe the student table again, if I just click on this and click run, now you'll see we have that extra column in here, GPA, and it's a decimal 3, 2. So that is how we can drop a table, and that's also how we can alter a specific column. If you wanted, you could also drop a specific column. So I could say alter table student, and over here I can just say drop column and just type in the name of the column. So what this will do is it'll drop that GPA column from the table. So let's go ahead and run. We get the success message. Now if I describe the table and I click run, you'll see that the GPA field went away. So I actually dropped that field. So you can create tables, we can add columns onto tables, we can remove columns from tables, and then we can just remove the table altogether. So hopefully that shows you guys some of the basics of doing those operations on tables. Now, obviously, whenever you're creating your database, the first thing that you want to do is define your database schema. In other words, you want to create all the different tables, and then you can start inserting data into the tables as such. So in the next tutorial, I'm going to talk to you guys about inserting data into tables. So we'll actually insert some student information into our student table. In this tutorial, I'm going to talk to you guys about inserting data into student tables, then type out values. So basically we're saying insert into the student table the values, and then over here I'm going to make an open and close parentheses and a semicolon. So now this is actually a full statement. So remember, we need to end this off with a semicolon. Inside of these parentheses, I can set up, so in another typing out command on this quick student. First thing we want is in the same
hit the road, Jack. Ooh. Wait, I haven't dropped it. I can. Okay, so it's just like Titan.
the first student, Jack, who's a biology major.
Is there a way to do it like automatically? It's a bit redundant. Okay. Middle check. Oh, they're right. Retype that.
And student ID is 1, and you can see we just keep going from there. So I'm going to insert, roughly this same information. So the first thing we want to do is put the student ID, so that's going to be 1. And you'll notice that with an integer, I
I've
can just
watched
type out the
this
number 1.
video.
And then over
Like,
here, we're going to put in
the
a
first
varchar 20. So
hour,
basically, this is going to be a
like,
string. Anytime we're typing out here, we come up with value, click on those. We can actually put this towards student, and this is going to go ahead and give us all the information from the student table. So I'm just going to click on this query here, and I'll click run. And you'll see down here, we get this table. So it says student ID 1, name Jack, major biology. So far in the student table, we have one student, which is Jack, and he's a biology major. So why don't we actually insert another student? So I'm going to keep this same line of code, except now I'm going to insert a student with ID 2. And this student's name is going to be Kate, and she is going to be a sociology major. So we have Kate, whose ID is 2, sociology. So if I click on this command here and I click run, this is going to go ahead and insert Kate into the database. So now I'm going to click on select all from students, or select asterisks from students, and we'll click run. And now you can see we're getting all the information from the student table. So we have Jack, and then we also have Kate. So we added in, so far we've inserted in 2 people into there. So what you could do is you could basically use this same format in order to keep inserting students. Make sure to type in this value section, like if I don't know what the major is, like I can't obviously put anything there. So by saying student, open and close parentheses, and then specifying the 2 attributes that I do have, I can then just put them over here and I won't get an error by not including it. So now we can change these values. So we'll change the primary key to 3, and then let's see who the next student in our database is. So it looks like it's Claire. So we'll have Claire, and then we can go ahead and run this query, and you'll see rows affected 1. So we added in another row. But if I was to select all this data, so I'm going to click select again, and I'm just going to click run. Now you'll see that Claire's student ID is 3, her name's Claire, but her major is null. So we didn't actually enter in a major for Claire, and therefore inside the major field, she's getting a value of null, and that's actually pretty common. So that's basically going to be what happens when we don't enter in something. And so what you can do is you can specify what pieces of information you want to insert into the table by specifying them over here. And then here in the values section, you just have to add those pieces of information. So that's 2 ways that you can insert. Get entry primary with this to 4, and so we're all good to go. 2 entries 4. Now this is this to 4.
Duplicate entry 3 for primary key, but
So instead of having an ID of 3, it's 4. Now this is going to work, and we'll be able to see we have 2 entries with Claire, but they have different student IDs, so we're all good to go. So that is the basics of inserting stuff into a table, and really those 2 techniques are really useful. So that's kind of the basics of inserting into a table. Now there's a lot of more things we can get into with this, and in the next tutorial I'm going to show you guys some other stuff that we can do in order to make inserting into the tables a lot easier. In this tutorial, I'm going to talk to you guys some more about inserting information into a database. So in the last tutorial, we kind of looked at the basics of inserting information. So we have our table here, it's the student table, and down here we kind of looked at how we can insert information. So we can say insert into the name of the table and then values, and we can pass in the values. We could also say insert into the name of the table, and then over here we could specify what information we want to insert. And then here in the values, we just insert that information. So we've kind of been using this photo over here of this student database. And I actually just went ahead and wrote out all the code for inserting all of these different students into the database. So you'll see we're inserting Jack, who's a biology major, Kate, sociology, Claire, who doesn't have a major. There's another one named Jack, who's also a biology major, but you'll notice that it has a different primary key than this guy up here. And then there's Mike, who's computer science. So these instructions will actually insert each of those students into our database. And you'll see over here when I run this select asterisks from command. So with PopSQL, if you just click on the SQL statement and then you click run, it'll go ahead and run it for you. So you'll see down here, we get all that information. So our database is set up. And that's sort of like the general use case, right? That's like we set up our database table and we're just straight up inserting information into it. But there's some other stuff we can do. Namely, we can actually set up our database table in order to make it easier for us to insert elements or to control the type of information or the type of rows that we can insert into the database table. So what I'm actually going to do is I'm actually just going to drop this table. So I'm just going to say drop table student, and we're actually just going to start over. So again, with pop SQL, all you have to do is click on the SQL command. Like I can click on drop table right here, and then when I click run, it'll go ahead and drop it. So now if I try to select all from the student table, you'll see it says there's no such table. So let's go ahead and I'm going to show you guys how we can create this student table in order to make it a little bit easier for us to insert stuff. So the first thing I'm going to show you guys is something called not null. And not null will basically allow us to define that a particular column in the table cannot be null. So let's say that when we're storing our students, we don't want the student to be able to have a null name. And null is basically just a value that represents no value. So if something is null, it means
save this. Wait, I cannot save this line of code to make me remember it. Wait, really? Really? Oh. Yeah. Oh, for fuck's sake. I don't know what's the fucking. That's fine.
that it doesn't have a value. So let's say that we always want the student to have a name no matter what. Well, after I say name varchar 20, what I could do is I could say not null. And I'm just putting that right after here. What that means is this column can't be null. So if you insert a row into the table, you can't insert null for a name. I could also do something else, which would be unique. So unique is another keyword which we can use. And basically what this is going to mean is that the major field has to be unique for each row in this table. So if somebody else or another row in the table has the same major as another entry, then that will get rejected. So not null and unique are actually pretty useful. So now what we can do is we can actually create this table. So I'm just going to click on this query and I'm going to click run and you'll see that we get a success message. So we were able to create the table. And so now why don't we start populating this table with information? So I'll come over here and I'll click insert into student Jack biology. So we're going to insert Jack and then we'll select the table and you'll see that Jack got inserted just fine. Let's click on this second one, Kate sociology. So we'll run this and again we'll just select all from the table. You'll see both of those got inserted. So now we get down here into this next one. So insert into student. So for Claire, we're inserting in student ID and name. Let's actually switch this up. So why don't we get rid of this and instead of saying this, why don't we'll give her a major. So we're gonna say that Claire's a chemistry major, but we're actually gonna get rid of this name. So instead of saying Claire, I'm just gonna say null here. And you'll notice up here, I said that the name cannot be null. So when I created this table, I specified that the name field cannot be null. So if I come down here and I try to insert a student with no name, with a name that's set to null, and I click run, you'll see that we get this error and it says you have an error in your SQL. And basically what that means is we can't insert in a value here that's null because we specify that it can't be null up here. So you're actually not going to be able to do that. Now, we also, over here on this major field, we define that it has to be unique. So if I come down here and I try to execute this line, so you'll see we're trying to insert, this person's name is Jack and they're a biology major, but we already defined one person that was a biology major up here, right? It was this first one. So if I try to enter in another biology major, it's going to give me another error. So I'm going to click run and you'll see down here it says duplicate entry biology for key major. So it yelled at us because we entered in a duplicate entry. So not null and unique are really good ways for you to kind of control the data that gets stored on the table. And actually, funny enough, if you have a primary key is actually just an attribute or a column on the table that is both not null and unique. So a primary key is basically just something that's not null and unique. So there's a couple other ones. So we're actually going to drop this table again. So I'm just going to click drop table and we'll go ahead and drop the table. And over here, I'm going to create the table again, but we're going to give this some other stuff. So these are actually what we would call.
Wait, how do I drop a column? On like a row. As if I want to drop the
Constraints. So I would say like a constraint would be that it's not null or that it's unique, but there's a couple other constraints that we can add that I want to show you guys. So let's say that we wanted to set a default value. So let's say that if somebody didn't enter in a major, we wanted to be able to give them a default major. Well, I can actually say that something has a default. So I can come down here and I can say after major default, and then inside of single quotes, I can just type in what I want the default to be. So in our case, if somebody doesn't provide us with a major, why don't we just say that they're undecided? So basically, if the major field is left blank, we'll say that the person is undecided. So then down here, why don't we go ahead and insert a student into the table that doesn't have a major. So here we can just say insert into student, and we'll go ahead and specify that we're going to insert in the student ID and also the name. But you'll notice that I'm not putting major in here, which means that we don't have to give this a major. So now we'll get rid of Jack's major, and when I go ahead and run this, you'll see that we got a success message. And if I was to select all the entries from the student, it says student ID is 1, his name is Jack, and his major is undecided. So because I didn't insert a major, it's going ahead and populating that major for us with the value undecided, because that was the default value that I placed over here. So that's another really useful constraint that we can put on this. All right, so there's one more of these little constraints that I want to show you guys, and it's actually really useful for working with primary keys. So you'll notice that the primary keys for all of these guys were like 1, 2, 3, 4, 5, etc. Right? I like manually went in and incremented all those primary keys. But what you can actually do is you can have the database do that for you. So I can come over here and right here after student. So remember, student ID is the primary key, right? We define that down here. I can come over here and say auto increment. And auto increment is basically going to specify that the data that gets inserted into here is going to get automatically incremented every time we add one in. So I can actually come down here and instead of inserting a student ID, I can just leave it out. So I could just insert the name and the major. And increment is basically going to specify that the data that gets inserted into here is going to get automatically incremented every time we add one in. So I can actually come down here and instead of inserting a student ID, I can just leave it out. So I could just insert the name and the major, and then I can add that information in here. So Jack is going to go ahead and study biology. And actually, let me get rid of these so we can kind of see how this works. So I can copy this for another one, and we'll make this Kate, and she's studying sociology. So notice that I'm not actually inserting the student ID, right? All I'm inserting is the name and the
column count is an message. ID name major. Wait, it's that right? Yep.
biology. And actually, let me get rid of these so we can kind of see how this works. So I can copy this for another one.
Oh.
And we'll make this Kate, and she's studying sociology.
Okay. Maybe like name. Maybe. That. Oh, hot. Okay. So this undecided.
So notice that I'm not actually inserting the student ID, right? All I'm inserting is the name and the major. But because we said that this table was going to be auto-incremented, in other words, because we said that the student ID was going to be auto-incremented, we don't actually have to do that. So I can come down here and I could run this, and actually, whoops, I have to create the table again, my bad. So we're going to create the table, and I can insert in this first entry, Jack, who's a biology major, and I'll run this, and you'll see it says one row affected. And I'm also going to insert this next one, Kate, who's studying sociology, so I'm just going to click run. And so now I've inserted both of these students into the table, and if I select all from the student table, you'll see down here that we get both of these entries. But Jack has an ID of 1 and Kate has an ID of 2, even though I didn't rigorously specify that, right? So I didn't actually add in the IDs for either of these guys, and yet they still showed up down here in the table, which was pretty useful. So that's a great way for you to just like automatically increment like something like a primary key or really any other row in the table by using auto increment. So those are just a couple little things that you can do when you're creating the table. We would call those constraints. So you can add constraints onto the specific columns of the table, and that can control like what types of information can be put inside of there. So that's just a little bit more of an advanced way for you guys to insert information into the database. In this tutorial, I'm going to talk to you guys about updating and deleting rows inside of a database table. So in the last few tutorials, we've looked at creating database tables and
Lihat. Nah.
inserting information into them. But now, once we have that information inside those tables, I'm going to show you guys how to update it and delete it whenever you want.
Wait. What I? Okay.
So,
Image kata image. Wow. I want to see the fucking image. Lihat. There it is. Oh, Claire. I can do this one. Yeah.
In this tutorial, I'm going to talk to you guys about updating and deleting rows inside of a database table. So in the last few tutorials, we've looked at creating database tables and inserting information into them. But now, once we have that information inside those tables, I'm going to show you guys how to update it and delete it whenever you want. So we have here our student database, and this is, or the student table, and it's the table that we've been using throughout the course. And so down here you can see it's just a bunch of students, and they have names, majors, and IDs. So right now these are all the students that are stored inside of our database. So these are the database entries that we can work with. The first thing I'll show you guys how to do is update some of these entries. So let's say that we wanted to update something. So let's say that we wanted to change the name of one of the majors in our school, right? So let's say I am the database administrator for my school, and we decided that instead of calling the major biology, we wanted to call it bio. So the official name for the major is no longer biology; it's just going to be bio. Well, we can actually make that change inside the database. So I can use a special keyword called update, and I can just type out the name of the table where I want to do the update. So in our case, it's student. And over here, I can say update student, and I want to set major equal to bio, right? But here's the thing. I don't want to set the major equal to bio for all the students. I only want to set the major equal to bio for the students who have their major as biology. So over here, we can specify that. I can say where, and here I can put a condition. So I can say major is equal to biology. And I'm going to put a semicolon. So this whole thing now is one SQL statement or query. So what I'm doing is I'm updating the student table, and I'm setting the major column equal to bio where the major column is already equal to biology. So now if I was to go ahead and run this, you'll see it says rows affected 2. So we updated 2 of the rows in this database. And if I was to select all of them, and I'm going to click run, you'll see down here now for the 2 students who are biology majors, it's now saying that they're bio majors, right? So it updated the database only in those places where the student's major was equal to biology. And that's what we can do here. So this is just a very basic update statement, but we can use this in order to do all sorts of stuff. So let's do another one. We could do the same for computer science. So I could say update student, set major equal to comp sci, where major equals computer science. So I'm basically abbreviating this major. So let's go ahead and run this. And
Wait, it's juga gini bang. Itu gini. Buat gua gitu kan. Anjay.
again, I'm just going to select all from the table. You'll see down here, Mike, who used to be a computer science major, is now a comp sci major. So I was able to update that. Another thing you can do is you can update specific things. So I could say like update student set major equal to comp sci where, and then over here I could do a different condition. So I could say like student ID is equal to 4. So now I'm updating the student's major who has an ID of 4. So this is like a different type of query. So down here I'm running that, and then I'm going to select all. So now you can see that Jack, who used to be a comp sci, or used to be a biology major, is now a comp sci major because his student ID was 4. So you can get kind of creative, playing around with setting different things and then checking different conditions. You can also use more complex conditions down here. So down here we have bio majors and we have chemistry majors, right? Well, let's say that any student who is either a biology or a chemistry major is now going to be a biochemistry major. So we're combining those 2 majors together. Well, I could update that here. So I could say update student set major equal to biochemistry, where major is equal to bio. And over here we could say or, and then we could also say major is equal to chemistry. And this is going to give us some or logic. So now if the student has a major of bio, or if they have a major of chemistry, we're going to set it equal to biochemistry. So we're basically combining those 2 majors together. So now I'll click run. And you can see rows affected is 2, and I'll select all from students. And you can see now Jack and Claire, Jack used to be a bio major, Claire used to be a chem major, are both now biochemistry majors. So you can use or in order to check multiple things like that. You can also set multiple things. So over here, I'm actually going to get rid of this condition, and I could say set name equal to Tom and major equal to undecided, where student ID is equal to 1. So whoever has a student ID equal to 1 is going to have their name set to Tom and their major set to undecided. So let's go ahead and run this. And you'll see it says 1 row affected. So let's select all from the students table. You'll see down here the student with the ID of 1 is now named Tom and their major is undecided. So you can change multiple columns within the same query like I did up here. right, so there's one more thing we can do, which we can actually get rid of this where. So this is actually optional. So if I got rid of where, I could then set something. So why don't we set major equal to undecided? So if I get rid of that where statement, this is just going to apply to every single row in the table. So now when we run this, you'll see rows affected was 5. And now when we select all from the students table, all of their majors are now undecided. So you can either select specific rows or groups of rows with that where, or you can just do it to all of them by dropping the wheres. So now I'm going to show you guys how we can delete rows from the table. And it's actually pretty similar to how we update rows. So instead of updating a specific row or a group of rows, I could actually delete a specific row or a group of rows. So it's actually, like I said, pretty similar to update. I'm just going to type in delete from and then the name of the table. So in our case, it's going to be student. And you can actually just end this off right here. I can put a semicolon here, and this will go ahead and delete all of the rows inside of the table. But why don't we try to get more specific? So I'm going to try to delete a specific row. I can say delete from student where, and now I can specify a condition. So I can say like where student ID is equal to 5. So what this will do is it'll delete any students or any rows from the table that have a student ID of 5. So down here we just have one like that. So Mike, who's an undecided major, has an ID of 5. So if I was to run this, now you'll see it says rows affected 1, and we'll select all from students, and Mike is no longer inside the table. So we actually deleted a specific row. And just like update, you can get more fancy with these queries. So I can say like where name is equal to Tom, and you can also do an and. So instead of doing or, we're doing an and here, and I can say like major is equal to undecided. So this will
Tom, man. What's up with the internet here? Oh. I'm learning here. Bisa start from 2. That.
will delete any students from the table who have a name of Tom and who are an undecided major. So now when I run this query, you'll see, and I select all the students again, that Tom got deleted from the table. So he's no longer there. So just like we used where in the update statements, we can use where with the delete statements to do all of that. But if you wanted, you could just delete everything from the table. So now I'm just going to run this command, and if I query the table, you'll see that nothing's there. So we deleted everything. So updating and deleting is extremely useful, and you can use that where statement in order to specify what specific row you want to update and what specific row you want to delete. In this tutorial, I'm going to talk to you guys about getting information from the database. More specifically,
okay, but we need to this. All of this.
we're going to look at the select keyword, and we're going to look at the different ways that we can ask the database management system to give us some information back. So one of the core tenets of interacting with the database management system and using SQL, ask the database management system to give us some information back. So one of the core tenets of interacting with the database management system and using SQL is writing these little there. So we deleted everything. So updating and deleting is extremely useful, and you can use that where statement in order to specify what specific row you want to update and what specific row you want to delete.
Queries. Now.
Select keyword, and we're going to look at different ways that we can ask the database management system to give us some information back. So one of the core tenets of interacting with the database management system and using SQL is writing these little queries. And a query is essentially just a block of SQL that's designed to ask the database management system for a particular piece of information. And so one of the things that we need to be aware of is that when you're keeping track of huge amounts of information in a database, you want to be able to grab specific information easily. So let's say that I'm trying to grab a bunch of students from our little student table right here. Well, imagine that we had like 1 million students stored inside of that table, right? I might not want to just grab every single student. I might want to just grab students who meet a certain condition, or students who have a certain major, or students with a certain name, right? And we can use SQL queries in order to specify those things. So instead of the relational database management system giving us back all the entries in a specific table, instead it can just give us back very specific entries which meet a certain condition. So we're going to talk a little bit about the basics of doing that stuff. Now this is actually a huge topic, and it's the topic that we're going to be talking about for most of the rest of the course. So this is going to kind of give you guys an introduction into writing all these little queries. So over here you'll see that I have this query here, and it's just select star from student. And actually, if you want, you can put this on 2 different lines. A lot of people will do that. So this select keyword is a very special word, and this select keyword is basically going to tell the relational database management system that we want to get some information from it. So I can say select, and then right next to it I can specify what information I want to get. Now so far in this course we've been using this star or this asterisk, and basically the asterisk means that we want to grab all of the information. But if we wanted, we could specify a specific column. So we can select specific columns of information that we want to get back from the database management system, and then we can say from whichever table. So select star from table could also be read as select every column from the student table. So over here you'll see when I run this, we get this information down here. So we're getting all of the students in the table. We're getting their student IDs and their names and their majors. If I wanted, I could change the columns up here though. So I could say like name, and now what this will do is it'll select all of the names from the student table. So if I was to run this query, you'll see down here here we get just the names. So we have the name, and then it's Jack, Kate, Claire, Jack, and Mike. So these are all of the names that were stored inside of the database. I could also include something else. So I could say name, major from student, and then down here, when I run this query, you'll see we're getting the students' names and the majors, but we're not getting the student's ID. So we're able to specify which specific columns we want to get back. You can also prepend these with the name of the table. So I could say like student.name and student.major. And sometimes people will do this just because student.name, it's clear which table the name is coming from. And as we write more and more complex queries, that can come in handy more. So for the most part, I'm probably going to be writing them both ways, just depending on the situation. But you could do something like this. We can also order the information that we get back. So here I'm getting the student's name and the student's major from student, and if I wanted, I could order that information. So I could use another command.
Wait. What is it? It's redundant. Oh wait, if I do this, then it's redundant. We're gonna do this. So if this is like student name, student major, the name of the student, then if I do this, it's gonna be like it's name in column student from column from the, a name from table student from table students.
Which is order by, and then over here I can just put the name of the column that I want to order these by. So I could say order by name, and now when I run this, you'll see we get the same results, but they're in alphabetical order based off the name. So we get Claire, Jack, Kate, and Mike. So these are now ordered in alphabetical order. And by default, these are going to be in ascending order, but if you wanted, you could put them in descending order. So you could say DESC, and this stands for descending. So now if I run this, you'll see that all the names get returned in the opposite order. So Claire is all the way at the bottom, and then we go all the way back up to Mike. So you can order by anything. So I could even order by like student ID. So I'm not returning the student ID. In other words, I'm not getting the student ID up here, but I could still order by it. And so now these are going to be in descending order of student IDs. So actually, why don't we just get all of these now? So I'll just say select all from student, and you'll see now it's ordered in descending order by student ID. It's a little bit clearer, 5, 4, 3, 2, 1. But I could also get rid of it, or I could just say ASC, which stands for ascending, and now it will order them in ascending order. So you can order by a bunch of different stuff. You can also order by different subcolumns. So I could say like order by, and we'll start with major, and then after that we'll do student ID. So select all from student, order by major, and then student ID. So it's going to order them by major first, and then if there's any of them that have the same major, it'll order them by student ID further. So I'm going to run this, and you'll see down here it's ordering everybody by major. So we're getting biology, chemistry, computer science, sociology. In this case, these two students have the same major. They also have the same name too, but their student IDs are different. So the student IDs are now ordered in ascending order. But if I said descending right here, and I run this query, now you'll notice that the biology major with student ID 4 came first and then 1. So it ordered it first by major, and then within that, if they have the same major, it ordered them by student ID. And you can specify as many of those as you want. You can also limit the amount of results you're getting. So I could say like select all from student, and then I could say limit, and here I could put like 2.
Okay.
And now what this will do is it'll limit the results I get back to 2. So now instead of getting all the students back, we only got 2. So if you only want like a specific number of rows back from the table, then you'll only get that. And you can also combine these. So I could also like order them. So I could say order by student ID descending. So now this is going to select all the students, order them by student ID, and only give us 2 of them back. So now when I run this, you'll see we're getting 2 back, and it's ordering them in descending order by student ID. So that can be pretty useful, and that's just another way that you can make these more complex. The final thing that we can do that I'm going to show you guys in this tutorial is filtering. So I could say where. So if you remember in a previous tutorial, we were updating and deleting students, and we wanted to only update or delete specific students where certain conditions were true, and we use this where condition. You can do the same thing for select. So I could say like select all from student where major is equal to biology. And so now this is only going to give us the students who are biology majors. And you can see down here we get back the 2 Jacks who are both biology majors. You can do the same thing for chemistry. So let's see if we have any chemistry majors. We do. Looks like Claire is a chemistry major. And if you wanted, we can only return specific columns, like I said. So we could say select, the name and major from student where major is chemistry, and now we're only getting the name and the major back. And you can make these more complex. So I could say like where major is equal to chemistry or major is equal to biology. So now this will give us all of the chemistry and the biology majors. So we get the 2 Jacks and Claire. And we can also do different things. So I can say like where major is equal to chemistry or name is equal to Kate. And so now we'll get back any of those students. So we get back Kate and Claire, and they have different majors. So you can play around with those where statements to get specific entries from the individual table. So I want to talk to you guys about how we can make these wheres a little bit more complex. So obviously over here we're using equals, but there's a bunch of other stuff you could use too. So and this is actually a comment in SQL. So if you put 2 dashes, then anything after it is going to be a comment. But here I have all the different comparison operators. So we have equals. We also have less than, greater than, less than or equal to, greater than, equal to, not equul to, which is these less than, greater than signs, and then and or. So you guys have seen some of these, but we can use these. So I could say like major not equal to chemistry. So this is going to select all the students where the major is not equal to chemistry. So if I run this, now we get all the students except Claire because Claire is a chemistry major. Or we could do the same thing for numbers. So I could say like student ID. So select all the students where student ID is less
Whoa,
than 3.
what the fuck is
This is gonna, so we have equals, put two where statements to get specific entries from
What
the
the fuck
individual
is
table. So I want to talk to you guys
that?
about how we can make these wheres a little bit more complex. So obviously over here we're using equals, but there's a bunch of other stuff you can use too. So and this is actually a comment in SQL. So if you put two dashes, then anything after it is going to be a comment. But here I have all the different comparison operators. So where we have equals, we also have less than, greater than, less than or equal to, greater than, equal to, not equal to, which is these less than, greater than signs, and then and or. So you guys have seen some of these. But we can use these. So I can say like major not equal to chemistry. So this is going to select all the students where the major is not equal to chemistry. So if I run this, now we get all the students except Claire because Claire is a chemistry major. Or we can do the same thing for numbers. So I can say like student ID. So select all the students where student ID is less than 3 and get rid of this. So now we'll get all the students who have student IDs. Let me get all of these. So we're only getting students 1 and 2. We're not getting anything. Or we can do less than equal to 3, and now this will also give us that student ID equal to 3. And you can combine these. So like where student ID is less than 3 and name is not equal to Jack. So if we run this now, you'll see we get Kate and Claire, but we don't get Jack, who is student ID number 1, because it didn't fit the condition. So you can use all these comparison operators to compare different things, and by using them inside of this where statement over here, you can like seriously filter the results down to only like the few that you need. All right, so I want to show you guys one more cool thing we can do, which is using the in keyword. So instead of just like putting a little condition like this, we could say where, and then we could say like the name of one of the columns, so like name, and then I can say in, and then over here I can put some parentheses and I can put some values in here. So if the name is Claire, Kate, or Mike. So basically what this is saying is select all from student where the name is in these, like this group of values, right? So if the name is Claire, Kate, or Mike, then it's going to select that. So now I can click run, and you'll see down here we get all the entries, Kate, Claire, and Mike. So this is a really easy way to compare like one column to a bunch of different values. So like we can check to see if the name is in there. We can also do the same thing for like major. So like where major in biology or chemistry. And now if we run this, you'll see that we get Jack and Claire because they're both biology. So that's, we can use in, and you can also combine all these things together. So you could say like where major in biology and chemistry and student ID is greater than 2, right? And now I'll click run, and you'll see that we get these 2 students, right? So you can combine the selects and the where and even like the limits and all that other stuff to make these kind of complex queries. But that's sort of the basics. And this is just, and tables, like getting information can get pretty complex. And as we go forward in the course, we're actually going to design a more complex database scheme. And you'll see that we get these 2 students, right? So you can combine the selects and the wheres and even like the limits and all that other stuff to make these kind of complex queries. But that's sort of the basics of doing these queries. I mean, obviously these are very simple queries, and as the database schemas get more complex, the queries that you need to select specific pieces of information are also going to get more complex. Now we're just using one table here, right? We're just getting information from the student table. But if we had multiple different tables, maybe certain tables had like foreign keys to other tables, like getting information can get pretty complex. And as we go forward in the course, we're actually going to design a more complex database schema. And using that database schema, we're going to learn more about using these select commands. But for now, that kind of shows you guys the basics. And so what you want to do is just kind of play around with these, right? I mean, we have our student table. It's very simple. It has 3 columns, and just play around with getting specific pieces of information using these wheres and ins and all these different keywords in order to select the information that you want. In this tutorial, I'm going to introduce you guys to a more complex database query that we're going to be using for the rest of the course. So up to this point in the course, we've learned a lot of stuff with SQL. We learned how to create tables, insert data into those tables. We learned about the different data types. We also learned how to update and delete data, and we learned how to query and select data from the database, right? So we learned a lot of the core concepts in SQL. And up to this point, if you guys have been following along, then you have a pretty good fundamental understanding of the different things that we can do in SQL. Now, obviously, we didn't cover everything, but we covered a lot of the basics, right? And we've been using this student table, which just has 3 columns, one primary key, and we learned how to create this table, we learned how to insert all this information, we learned how to update and delete, and then also just query for the specific language. Here's the problem, though, is this is a very simple example, right? I mean, it's one database table, and it only has 3 different columns. But in reality, database schemas are going to be a lot more complex than this, right? The chances of your database schema just having one table is going to be pretty slim. And so, to really master SQL and to really, learn about all the different features, and there are certain features that we haven't covered yet that I want to cover, we're going to need a more complex database schema, right? There's certain things that I just can't show you guys on the student table because it's just not complex enough, right? So what I actually did is I went ahead and designed another database schema. So I actually designed a database that could be used for a company. So I'm going to go ahead and pull that up. And right here we have our company database. And you can find this PDF in the description below. I'll put a link to it. But basically this is the database schema that we're going to be using for the remainder of the course. So this is a more complex database schema. But because it's complex, it's going to give us some awesome opportunities to query it, right? In other words, the more complex the database schema, the more complex the queries we're going to be able to write and play around with. Because there was only so many types of queries that we could write for that student table. But this is going to be a better example for us to learn about different types of queries and stuff like that. So I'm going to go ahead and walk you guys through this schema in this tutorial. That way you guys understand it. Because if you can't wrap your head around it, then you're not going to be able to follow along with the rest of the course. So I'm just going to give you guys an explanation of this, and that way we have it going forward. So this database schema maps out the database for a company, right? So this would be like the information that we might want to store about a company. So up here we have our first table, which is the employee table. And so this is just going to store information about employees. So we're storing like the employee ID, the first name, the last name, birth date. As you'll see here, this is actually a date, sex, which is going to be male or female, salary, which would be like how much they make. And then over here we have 2 foreign keys. So the primary key of this table is the employee ID over here, which we have in red. The foreign keys are going to be these keys over here in green. And basically a foreign key is going to store the primary key of an entry in a different table, right? So we have 2 foreign keys. The first here is super ID. That stands for supervisor ID. So an employee in our company is going to be able to have a supervisor. And a supervisor is actually going to be another employee. So super ID is going to point to another employee in the employee table. We also have branch ID. So different employees in the company are going to be able to work for different branches. And you'll see down here, we have this branch table, and it just has a branch ID, a name, and then also some other stuff, which we'll talk about. So an employee can work at a branch, right? And that's kind of what we're storing over here. So let's take a look at this. We would say that the employee Michael Scott, his super ID is 100. That means Michael Scott's supervisor has an ID of 100. So Michael Scott's supervisor is going to be David Wallace, right? Because David Wallace has an employee ID of 100. Kelly Kapoor has a supervisor ID of 102. That means Kelly Kapoor's supervisor is going to be employee number 102, so it's going to be Michael Scott, right? So hopefully that makes sense, right? An employee can have a supervisor, and super ID is a foreign key, which points to the employee ID of another employee. And then we also have branch ID over here again, and this will point to the branch. So branch ID, Angela Martin has a branch ID of 2. That means Angela Martin works at the Scranton branch. Andy Bernard has a branch ID of 3. That means Andy Bernard works at the Stanford branch. So hopefully that kind of makes sense. And then down here, like I said, we have the branch table, and the branch table just has an ID, a name, and it also has a manager ID. So on the branch table, we're actually storing the ID of an employee who is the manager. So this is actually a foreign key. So manager ID is going to point to one of the employees up here. So we would say that the manager of the Scranton branch has an ID of 102. So the manager of the Scranton branch is going to be Michael Scott because he has a 102. The manager of the Stanford branch has an ID of 106. So the manager of the Stanford branch is Josh Porter because he has an ID of 106. Hopefully that makes sense. And then we're storing the date that the manager started being the manager. So now we'll check out the client table. So the client table has a client ID, client name, and also has a foreign key, branch ID. So we would say that the client Dunmore High School, works with branch number 2, or the client Times newspaper works with branch number 3. So Dunmore High School would be a client of branch number 2, which is the Scranton branch over here, right? Hopefully that makes sense. The Times newspaper is a client of branch number 3, which is the Stanford branch. So that's kind of how those are connected. And then over here we have another one, which is branch supplier. So this has a compound primary key, or a composite key. And the first part of it is the branch ID. So a branch supplier is obviously going to store the branch ID, and it's also going to store a supplier name. So it's important to notice that we need a composite key here because the branch ID doesn't uniquely identify each row, and the supplier name doesn't uniquely identify each row. Only together can they uniquely identify each row. And then the last table down here is the works with table. So this basically defines the relationship between employees and clients. So we're going to go ahead and assume that an employee can work with a client and sell the client like different products, right? So employee 105 sold $55,000 worth of paper to client 400. Employee number 108 sold $22,500 worth of product to client ID 402, etc. So this is kind of mapping the relationships between employees and clients and telling us how much a certain employee sold to a certain client. And you'll see this is also a composite key. So this is the database schema that we're going to be working with for the rest of the course. And like I said, in order to kind of show you guys some more advanced SQL queries, we're going to need a database schema that is, complex, just like this one. If this isn't super clear to you, what you might want to do is just kind of look over the PDF that I'm going to include in the description below. And really what we want to do is just trace the relationships. So, really make sure that you understand how this database schema is put together, how everything relates to each other. And then going forward in the course, we're going to be using this database schema. So in the next tutorial, I'm going to show you guys how to create this. So I'm going to actually give you all of the code for creating this entire database. And then from there, we'll go ahead and we'll start learning some more advanced queries.
Where's the fucking PDF file? Where's the PDF file, cunt? It's the code. Giraffe man. Oh my god, this is so interesting. Go fuck yourself.
And some more advanced stuff that we can do. In this tutorial, I'm going to show you guys how we can create a complex database schema in SQL. So in the last tutorial, I showed you guys this database over here. It's this company database. This is basically just an example database that I created, and it's a database that we're going to be using for the remainder of the course in order to learn a little bit more advanced SQL querying and stuff like that. So this is a company database, and we have a bunch of tables like this employee table, branch table, works with table, etc. And in the last video, I kind of talked about what each of those did. We looked at some of the different relationships between the tables. So in this video, I'm going to show you guys how we can actually implement this database. So how can we take this database and actually create it in MySQL? So not only are we going to create all of these tables, and we're going to define all of these relationships like the foreign keys and all that stuff, we're also going to populate all of of that information. So I'm going to populate these database tables with all this information. That way we can use that information going forward for the example. So this tutorial is going to be pretty cool because I'm going to show you guys how to build an advanced database schema just like this, right? It's a little bit more complex than the student table we had looked at before. And before we get started, I just want to say all of the code that I'm going to be using in
Ada sesuatu di depan nih, lupa anjir. I know it's in ini krimen fuck key auto increment dude. Let's click primary key. It's gonna be like first underscore name of file 10, then last underscore name for car of 10, and then birth date of date. Since when do I need to wait? Huh? What?
this tutorial is going to be available in the description below. So there'll be a link that you can click on, and I'll have all of this. So you don't have to type out everything that I'm typing out. And in fact, I'm just going to be pasting in a bunch of stuff. So that way you don't have to type anything. So the first thing we want to do is we're going to drop that student table. So I'm just going to go ahead and drop table student, and we'll go ahead and drop that table. That way we don't have to worry about it. And so once we've gone ahead and dropped the student table, now we can start creating all of these tables for our company database. So I'm just basically going to paste in the code for creating each of these tables. I already have it all written out, and I'll kind of walk you guys through what it is and what we're doing.
Yeah, it's date on the date. What the fuck? Stop it. Salary is gonna be like is an integer, and then I don't know about that, dude. Super ID is integer. Is that got a fucking default of no, and then trans super ID is integer. Now this is the primary key. How the fuck do I
doing. So here we have create table employee, so we're going to create this employee table. We have our employee ID, which is an integer, and this is going to be the primary key of the table. And then we also have first name, last name, birthday. So birthday is actually a date, as you can see over here. We haven't used the date data type yet, but we're using it now. Date will allow us to store a date just like this with a 4-digit year, 2-digit month, and a 2-digit day. We're also storing their sex, so like male or female. And that's just a varchar one. We're storing the salary, and then we're also storing the supervisor ID and the branch ID. And if you guys remember from the last video, the supervisor ID is a foreign key, which points to another employee. And the branch ID is also a foreign key, which points to the branch table. Now, here's the thing. We can't actually make these foreign keys just yet because the employee table doesn't technically exist yet, and the branch table doesn't technically exist yet because I haven't created them. And so I can't define these guys as foreign keys just yet. We're going to do that later, and we'll add that in afterwards. So I'm going to go ahead and run this, and we'll create the employee table just like that. So now we're going to go ahead and create the branch table. So I have the code for the branch table right here. So we're going to create table branch.
yeah. Oh, I guess it's not really simple. Let me learn by fucking doing. Branch. Can I have a branch ID of integer auto underscore in primary key, and then we're gonna do, oh my god, branch name of for car 10 again. And then ngid of integer, and then ngl stuff instead of date. branch ID, integer value, yes, ooh, what is that? Foreign key, reference.
And this is just this guy down here. So it has a branch ID, which is the primary key, branch name, and the manager ID. So remember, the manager ID is down here in green. The manager ID is also a foreign key. So the manager ID we're actually going to be defining as a foreign key, which points to the employee table, and then we have the manager start with date, which is a date. So down here, I'm defining a foreign key. So in order to create a foreign key, I can just say foreign key, and then inside of parentheses, put the name of the column that I want to be the foreign key. In our case, it's manager ID, and then I can say that it references employee, and then inside parentheses, just the name of the column in the employee table, which is going to be employee underscore ID. And then finally, I'm going to do one more thing, which is over here. I'm going to say on delete set null, and we're going to talk more about what on delete set null does in a future video. But for now, just know that whenever we're creating a foreign key, we're going to put on delete set null, or we can also put something called on delete cascade, which again I'm going to talk about in a future video. But just put that in there, and that'll make it a lot easier for us to manage this foreign key. So now I'm going to go ahead and run this, and we'll create the branch table. So looks like that went well. All right. So next thing.
Wait, what's this? It's a bit of a... There's a space. Yeah.
What we need to do is we need to set the super ID and the branch ID of the employee table as foreign keys. So remember, down here in the branch table, we set the manager ID as a foreign key, but we weren't able to do that with the supervisor ID or the branch ID in the employee table because the branch table and the employee table haven't been created yet. So I'm going to show you guys how we can do that. So down here I have two little blocks of SQL code. The first one is altering the table employee, and I'm just saying add foreign key, and then inside of parentheses we're putting branch.
So if you have this, add foreign key reference on this. So what do I need to do? Super ID, EMP ID, jadi ya alter table employee add of super ID reference employee EMP employee that. Holy shit, I'm the best. Let's go. Alright. Pickle Rick. Employee, we're gonna do a branch underscore ID. We're gonna reference the branch ID. Yeah, employee, branch ID, branch ID. Wait, yeah, branch ID. Ooh, that's not. I'm the best.
branch ID, so that's going to be the foreign key, references branch, and then branch underscore ID, and on delete we're going to set null. And so what this is going to do is it's going to add branch ID as a foreign key to the employee table. So I'm going to run this, and now this is going to be a foreign key, and then down here we can do the same thing but for supervisor ID. So you see supervisor ID right there. I'm going to go ahead and run this, and this will add the supervisor ID as a foreign key, just like we did with the branch ID. So we needed to do that because when we created the employee table, the branch table and the employee table hadn't been created yet, so we couldn't add them as foreign key relationships. All right, so now we're going to add the client table. So you'll see over here, create table client, and we're just storing the client ID as
What is it called? Key. Foreign key.
a primary key, client name, branch ID, and then we're going to make the branch ID a foreign key. So over here,
Okay, let's. So it's gonna create table. It's gonna be named client open parenthesis. Don't forget this. What are we gonna make? While we're making boys, the first is client ID, which are an integer. It's gonna be a primary key. Forget. It's my code period. And for name, it's gonna be a car of 30. And there's gonna be a branch ID. Wait, integer and then integer. So we're gonna make it an integer first. ID of integer, and then we're going to make it a foreign key of mgr underscore ID, which references the branch mgr underscore ID, okay, and then that foreign key references branch. Yes, okay. Client ID integer manager worker of all and manager branch ID. Oh, it's a branch ID here, not manager. I'm sorry, Suka.
on the client table, you'll see that the branch ID is a foreign key. It points over to branch. So we're going to define that relationship here. I'm just saying foreign key branch ID references branch ID, and then once again we're just going to say on delete set null. So let's go ahead and create the client table. I'm just going to run this, and that'll create the client table. So next we have the works with table. So the works with table is actually pretty unique because it has a composite primary key. So the primary key has the employee ID and the client ID. And actually what's unique is that each component of the primary key is a foreign key. So employee ID is a foreign key and client ID is a foreign key. And so over here, we can create this table where I just have employee ID, client ID, total sales. The primary key is employee ID and client ID. And then the foreign keys are employee ID and client ID. And you'll notice over here, instead of saying on delete set null, I'm saying on delete cascade. And again, I'm going to talk more about on delete set null and on delete cascade in a future video. But for now, just know that you need to have this here in order for everything to kind of be set up correctly. So I'm going to go ahead and run this, and we'll be able.
Okay, I'm sick. You could go further. Worksheet. Six.
Able to insert or create the works with table. And then finally, we're going to create our last table, which is the branch supplier table. And this is actually kind of similar to the works with table. So down here, we have the branch supplier table. It also has a composite key, so its key is made up of multiple columns. And the branch ID column is a foreign key, but the supplier name column isn't a foreign key. So this one's actually pretty interesting as well. So we have branch ID, supplier name, supply type, and then the primary key is branch ID and supplier name, and the foreign key is just branch ID. And again, with this one, on the foreign key, that's also part of the primary key, I'm just saying on delete cascade. So that's going to be what we're going to need there. So I'm going to go ahead and run this, and you'll see over here that everything got entered correctly. So now we have all of these tables created, right? We created all the tables for our database schema. And so what we're going to do now is we're going to actually insert information into those tables. Now, when we're inserting information into these tables, because we have all of these like foreign key relationships, we're actually going to have to do it a specific way. And so I'm going to walk you guys through how we might do something like this, and it'll give you an idea of how you could do it. So I'm actually going to make the text a little bit smaller. So over here, I'm going to show you guys how we could insert all of the information for the corporate branch. So inserting the employee and the branch entries for the corporate branch. Now, notice over here that the employee table and the branch table have foreign keys that point to each other. So the employee table has an entry over here, branch ID, which points to the branch or points to a specific branch, and each branch has a column here, manager ID, which points to a specific employee. So there's like this circular relationship. So when we're inserting these elements, we're going to have to do it in a specific order. So over here, I'm just starting with, like I said, the corporate branch. So I'm inserting into the employee table values 100 David Wallace. So I'm inserting in this David Wallace row over here. And you'll notice that I put all this stuff in here. But when I get to branch ID, which is this last element over here, it should be 1, right? So David Wallace should belong to the corporate branch. But the problem is that the corporate branch hasn't been created yet. So I'm just going to set this equal to null because that branch hasn't been created yet. And I'm going to go ahead and insert David Wallace in there. So I'm just going to run this. Then what I'm going to do is I'm going to insert the branch into the branch table. So I'm inserting into the branch table values 1, corporate, 100. So now that since I already inserted the David Wallace employee, I can set David Wallace's employee ID as the manager ID on the branch row. And so now I'm inserting in the corporate branch. So I'm going to go ahead and do that. And then what I need to do now is I need to update that David Wallace entry to say that he works for the corporate branch, right? So down here I'm saying update employee, set branch ID equal to 1, where employee ID is equal to 100. So that'll go ahead and update David Wallace. So the last thing we're going to do now is just insert the last employee into the corporate branch. So you'll see Jan Levinson is actually getting inserted into there. So I'm going to go ahead and run this. And so now we have all of our employees inserted into the corporate branch. I'm going to do the same thing for the other branches. So we'll do the same thing for the Scranton branch. And here I have the code to do that. So again, I'm inserting in the manager of the Scranton branch. So I'm doing that right now, which is Michael Scott. Then I'm inserting the...
Chill out, man. Talking too fast. Funny, because I make him talk fast. What are you doing again? Oh yeah. Fuck, I forgot the syntax. Add table employee Kelly insert insert into. Sorry, man, it's first time. David. First name, last name, Wallace. Nineteen 11/17. You're crying out loud, Tom. The sex is really gay. And then Kevin, right now, and yeah, and then we're going to make the branch, maybe branch values, maybe like 1 core product. The entry ID gonna be 100. 2006 0209. Ooh. Ooh. Hell yeah. Ooh. And then we're going to alter table. We're going to alter a table. What table we're going to alter? The employee. We're going to update. Update employee. We're gonna set something. What are we gonna set? The branch underscore ID to 1 for where? Sorry, too many programming language in my head. Hurts, please. ID equals 100. Success. Then we're going to insert another son of a bitch, which are Jan. So you know what? Everything. 1961 or 511. Female. Ooh, lower pay grade, eh? I guess it is. True. Surprise is okay because it's already been defined, right? Which is the David Wallace. This one is okay because it has to define it. It's just
I'm saying update employee,
successful.
set branch ID equal to 1, where employee ID is equal to 100. So that'll go ahead and update David Wallace. So the last thing we're going to do now is just insert the last employee into the corporate branch. So you'll see Jan Levinson is actually getting inserted into there. So I'm going to go ahead and run this. So now we have all of our employees inserted into the corporate branch. I'm going to do the same thing for the other branches. So we'll do the same thing for the Scranton branch. And here I have the code to do that. So
And then another which are Scranton. First of all, it's going to insert into employee values of what? Of first of all 102 value Michael Scott. Date of birth is gonna be 1964 0315. Also, it's gonna maybe 100 and it's gonna be no. After that, we're going to branch insert into this. It needs to be one by one. Manager first and then branch. Insert into branch values. Nah, branch itu kan ini. Berarti if I'm not mistaken. Yep. Maybe Crampton. Maybe 102. Maybe too much. 24 or 4 or 4 or 6. Do it. And then we're not gonna alter, it's gonna be update table. Wait, not table, update employee in set branch underscore ID to 2 where employee ID is equals to 102. And then it was time for to run the jam. This was a bit much.
So again, I'm inserting in the manager of the Scranton branch. So I'm doing that right now, which is Michael Scott. Then I'm inserting the actual Scranton branch. And then I'm updating Michael Scott to say that he works at the Scranton branch. And then finally, I'm adding in Angela, Kelly, and I'm also adding in Stanley. So now I have all of the employees in the Scranton branch. And again, we have to do it that way because we have this like circular relationship with the foreign keys between the employee and the branch table. So then finally, we'll do the same thing for the Stanford branch. So I'm inserting the manager of the Stanford branch, and then I'm inserting the actual.
It's okay, you can see my second screen.
Actual Stanford branch, and then I'm updating the manager of the Stanford branch to say that he works at the Stanford branch, and then I'm adding in these other employees, so Andy Bernard and Jim Halbert. All right, so now that we've done all that stuff with the employee table and the branch table, we can kind of move on to doing the other ones, and hopefully that shows you how you might insert information, or how you might have to insert information into a more complex database schema, right? When we're just inserting into the student table, it's really easy, but when we have foreign keys like linking all over the place, it can get a little bit complicated. So now, though that is the most complex inserting we're gonna have to do, so now we can just insert normally. So we can insert into branch supplier, and I'm just gonna go ahead and click through all of these and insert them in.
No, it's normal insert. And then same as client.
Turn just like this. All right, so I've gone ahead and ran each one of these insert statements. So we inserted everything into the branch supplier table. Now I'm going to insert everything into the client table. And again, this information is just the information that you see over here. It's just written out into database or SQL commands. So I'm going to go ahead and insert each one of these. All right, and then finally we'll insert into the works with table. So again, this is just a bunch of numbers.
Numbers.
And stuff like that. All right, so now we've gone ahead and populated all of these database tables with all the information. So why don't we check it out? I'm going to say like select all from employees. So let's see all the different employees that we have. Make sure everything.
Wait, I forgot it. Wait. Oh. Select everything from employee. There it is. Beautiful child.
Work. So down here you'll see that we have all these different employees. We can do the same thing for like works with. So let's see if we got all that data, and you can see that we do. So now our database is actually populated with all of the information that I have over here. So again, you can get all that code from the description below. But hopefully this kind of shows you guys how we can go about designing a database schema, or go about creating a database schema like this inside of MySQL. You can see it's not as straightforward as it was with the student table, but we can do different things to make it happen. In this tutorial, I'm going to show you guys some awesome select statements which will allow us to query the company database that we've been setting up for the last couple tutorials. So basically, I'm going to give us some little prompts, and we'll see if we can figure out how to get the data. So the first thing we're going to do is try to find all employees. So our first task is to
it.
To get all the employees from the employee table. And you'll see over here, this is essentially all of the data that we have stored in our database. So let's see if we can find all employees. I'm gonna say select, and I'm just gonna say star. So select star would mean select all columns from the employee table. And this should actually do it. So just by saying this, I'm gonna run this and we'll see what we get. So down here in the results, we have returned all the employees. Cool, so we were able to get all of the employees. Let's try another one. How about we'll try to find all clients. So now instead of finding all employees, we'll see if we can find all the
client. Kenapa ditambah ini? Find all. So we're gonna select client name from client.
client. So basically it's the same thing, but all I have to do is change employee to client. So now we're grabbing information from the client table. So I'm gonna run this, and you'll see down here we're getting all of the clients. Cool. So that's how we can just get all this stuff from a single table. Let's try another one. Find all employees ordered by salary. So
ascending or descending, dude? Che risoluzione? A woman.
So this one is a little bit different. Not only do we want to find all the employees, but we want to order them by how much they make. So we'll say select all from employee, and now we want to order. So we can just say order by, and we want to specify what column we want to order these by. So we could say salary. So now I'm going to run this, and you'll see down here, now we get all the employees, but they're ordered by how much they make. So down here, this employee makes $250K a year, and it goes all the way down to $55K a year. Let's see if we can do this though. So the richest employee, or the employee that makes the most, starts. So we could say DESC for descending, and now this will list them all out in descending order. So the 250,000 guy starts up at
Finally, I'm curious by all of the 50s.
top, and then we go down to 55,000. All right, so that's pretty cool, and that shows how we could execute that query. So let's try another one. It says find all employees.
Dari sekali aja kayak dari extend order by sex, and then name, sorry, first name. All name.
Employees ordered by sex, then name. So what we want to do is order all the employees by what sex they are, and then within those orderings, we want to order them by their name alphabetically. So I can say select all from employees, same. Order by, this time we're going to do sex. And so why don't we do first name, and then we'll do last name. So now when we run this, you'll see here, all of these are ordered first by sex. So we get female, and then here's all the males, and then within that, they're actually ordered alphabetically. So we'll start with the first name. So Angela's first, then Jan, Kelly, and then these are all the girls, and then down here we have the guys. So Angie, David, Jim, Josh, etc. And then if there were any duplicates with the first names, or there were two that were the same, then we would defer to the last name as we specified up there. All right, let's try another query prompt. So we'll ask for a different piece of information. So it says find the first 5. 5 employees in the table. So this is a situation we could say from employee, select all from employee, and here we can limit it to 5 employees. So select all from employee, limit 5. That'll give us the first 5 employees. So you see down here, we just get the first 5 like that. All right, let's do a few more, and we'll see if we can mix it up a little bit. So let's try to find the first and last names of all employees. So this time we're actually just trying to get the first and the last name. So up here we could say, instead of select star, we can just select first name and last name, just like that. So over here, I'm gonna click run, and you'll see now, instead of getting all that stuff, we're just getting first and last name. So I'll actually show you guys another thing we can do. So here's the prompt. It says, find the forename and the surnames of all employees. So this is actually similar, but you'll see down here when we return to the first and last names, the columns were named first name and last name. But there's another keyword that we can use in SQL, which is called as. So I can say select first name, and I can say as forename, and we can say last name as surname. And what this is going to do is it's going to return the first names and the last names, but instead of naming the columns first name and last name, it's going to name them forename and surname. So we're going to go.
Oh, cool. Maaf, bukan aku, Tuhan SQL. Aduh. Oh, right.
Go ahead and run this. You'll see we get exactly the same thing, except now it's calling the columns forename and surname. So that's kind of a useful thing you can do, and there'll be certain circumstances where you want to name the columns differently depending on what you need. All right, so there's one more I want to show you guys, and I'm actually going to introduce you to a new SQL keyword. So the prompt is find out all the different genders. So what we want to do is figure out what are all the different genders that employees are stored as inside of the table. So
Unique. Okay.
what we can do is we can use a special keyword called distinct. So I can say select distinct, and then the name of the column that I want to select distinct. And what this is going to do is when I run this, you'll see down here we're getting MF. So we're getting male and female. So
Wait, what? Sexy. This thing.
column that I want to select distinct. And what this is going to do is when I run this, you'll see down here we're getting MF. So we're getting male and female. So those are all of the different sexes that are stored inside of the table. I can do the same thing for something else. So we can do like select distinct branch ID, and this will tell me all the different branch IDs that are stored on the employees. So you'll see down here we have different branch IDs 1, 2, and 3. So those are all of the distinct branch IDs that employees have. And so this distinct keyword is pretty useful if you want to find out like what are the different values that are stored in a particular column. All right, so that should kind of show you guys just a little bit more about how we can use these select queries. Kind of give you guys a chance to see how we might query data from the company database schema that we set up.
Oh, function!
I'm going to show you guys some SQL functions. Now, an SQL function is basically just a special little kind of like block of code that we can call, which will do something for us. So these will like count things, or they'll give us averages, or they'll add things together, and they can be really useful for getting information about the data in our tables. So I'm going to give you guys a couple different prompts, and then we'll figure out how we could solve them. So over here, I have a prompt that says find the number of employees. So this is kind of a maybe something that you want to do. We want to figure out.
Number 5. Is another one. Called function. Let's pass or I'll find the number of employees. Teach me, baby.
How many employees are in the database. So what I could do is I could say select, and I can use a special SQL function called count. So I can just type count like that, and then open and close parentheses. And in here, I want to put whatever I want to count. So basically, we could just put in like EMP ID, and this will basically tell us how many employee IDs are inside of the table. And since the employee ID is the primary key, that'll tell us how many employees we have. And then I can just say from employee. So basically, what I'm doing here is I'm asking SQL to select.
So if I do sex, it's gonna be 2 or 8. Oh, let's see. Want the sex, yeah. From so much sex on here. Why do you have 8, dude? Oh, because one of them is null. Okay.
How many employees are inside of the employee table. So when I run this, you'll see down here we get 9 because there's 9 employees inside of the table. And you can see over here we have 100 through 108, which is 9. Another thing we could do would be to count how many employees have supervisors. So this is going to be a different number. You'll see over here that one employee, David Wallace, doesn't actually have a supervisor. So we can check that out. We can say select, and I can say super ID. And now when I run this, we should get 8 instead of 9, which we do down there. So this will count how many entries in the database table actually have values. Another thing we could do, and here's another prompt, which should be kind of interesting to see if we can figure it out. It says, find the number of female employees.
Ooh, fun. Wait, ini kayak pelatihan table WOWOWOWO kemarin anjir. Find the number of female employees born after. Ooh. Udah selesai guys. I'm gonna wing it. I'm gonna wing it. 2.
Born after 1970. So this is a little bit more specific, but nonetheless, it's kind of the same. So first thing we want to do is count how many employees we have. So I'm going to select count employee ID from employee, but I want to limit the results that we get. So I'm going to say where, and here I'm going to check these conditions. So I'm going to say sex is equal to female, and birth date is greater than, and over here I'm actually going to put in a date. And so when I put in a date, I'm just going to put the 4-digit year. So I could say 1970 and then a hyphen and then put in the month. So we'll just say 01 and then 01. So this would be like January 1st, 1970. So this will tell us the number of female employees born after 1970. Or I guess we would put this as 1971. So let's run this, and now you'll see that we get a count of 2. So there are 2 female employees in the database table that were born after 1970. And you can see over here, looks like we have one born in 1971, Angela Martin, and then one born in 1980. So that actually makes sense. All right, let's try another one. Here's another prompt. It says, find the average of all employees' salaries. So this is a little bit different. In this case, we want to...
Oh, benar. Wait. Find the average of all employees' salaries. So, if we're going with the logic of count, it's gonna be like average. FVG? Yeah. Sorry. From employee, where? Wait. Yeah.
Find out the average of all the employee salaries. So instead of count, we can say AVG, and then inside of parentheses here, we can put again the column.
It's just
so
logic.
Salary, and then over here we could say from employee. And what this will do is it'll tell us the average of all the employee salaries. So go ahead and run this, average, and you'll see down here the average looks like $92,888. So if we wanted, we could filter this further. So let's say I wanted to find the average from all the employees who are male. So I could say where sex is equal to male, just like that. And now this will give us the average of all the male salaries. So here it looks like it's a little higher, 101,333. That's probably because David Wallace makes 250 grand a year. All right, so that's kind of interesting. Let's try another one. So how about this? Why don't we try to find the sum of all employee salaries? So instead
Jabla.
of finding the average, we're going to find the sum. So over here, instead of AVG, I can say SUM, and that stands for sum. What this will do is it'll add up all the entries for the salary. So this will basically tell us like how much the company is spending on payroll to pay the employees. So over here, I'm gonna click run, and you'll see the company is spending a total of $836,000 on payroll. So that's how much the company is paying its employees. I want to show you guys one more thing we can do, which is called aggregation. And aggregation is basically where we can use these functions and we can display the data that we get back in a more helpful way. So I have a prompt up here that will kind of get us started with this. So the prompt is find out how many
Ooh, I don't know about that.
males and how many females there are. So this is actually an interesting point. Let's say we want to figure out how many males or females were in the company. Well, I can say over here select count, and instead of saying salary, I'm going to say sex. And so let's say that we just did this, right? This is going to tell us how many employees there are that have a entry in the sex field, right? So we get 9. But if we wanted to also display how many males and how many females there are, we're going to have to do a couple things. Over here I can say count, comma, and then I can just say sex. So what this is going to do is it's going to return not only the count, but also it's going to return which sex it is. So I'm going to click run, and you'll see over here there are 9, and it says male. Males and how many females there are, we're gonna have to do a couple things. So over here I can say count, comma, and then I can just say sex. So what this is gonna do is it's gonna return not only the count, but also it's gonna
select count sex here, employee.
gonna return which sex it is. So I'm gonna click run.
What? Where's the difference? Select count sex from employee. Mate, it's drawing attention from me, but
And you'll see over here there are 9, and it says male. But this still isn't exactly what we want. So what we can do is we can come down here and we can say group by, and what this is gonna do is it's gonna group this information by the column that I put over here. So now when I run this, you'll see
wait, you can print that?
and I can just say sex. So what this is gonna do is it's gonna return not only the count, but also it's gonna return which sex it is. So I'm gonna click run, and you'll see over here there are 9, and it says male. But this still isn't exactly what we want. So what we can do is we can come down.
How do you do that? Cool.
Here and we can say group by, and what this is going to do is it's going to group this information by the column that I put over here. So now when I run this, you'll see it's going to tell us exactly what we want. So it's going to say 3 female and 6 male, and that's because I'm telling MySQL to group the information that it gets by sex. So it's counting how many entries or how many employees have a entry in the sex column, and then what it's doing is it's printing this data out alongside of whether they're male or female, and it's giving us that information. So that is what we call like aggregation, and it's a really awesome, and you can use this group by keyword to do that. So let's do that again. Why don't we try another one? Here's another prompt that we can look at. It says
Financial service salesman? Whoa! You weren't kidding about that. About my saying it's gonna get complicated real quick. We're just playing with the employee and now we're going to do another step. Okay. So we're gonna go to workfit, right? Wait. empty. Ooh. Oh, I don't know. Oh no. Some, but I don't know the name though. I just want to know the name. Must have 4. 102, 105, 107. Oh, there's only 4. How do I
find the total sales of each salesman. So this is kind of interesting, right? Down here we have this works with table, and this kind of gives us information about which employees sell what. And you'll notice I have like employee 105, right here, sold 55,000. Employee 105 also sold 33,000, and also sold like 130,000. So what if we want to figure out the total that each employee actually sold? Well, I can do something similar. So I can come over here and I can say sum, and here we're going to say total sales. and then over here we'll print out the employee ID. And instead of grabbing this from the employee table, we're going to grab this from the works with table, and then we want to group this by employee ID. So basically what this is going to do is it's going to tell us how much each employee has sold. So you'll see over here, employee 102 sold $282,000, employee 105 sold $218,000, 107 sold $31,000, etc. So we're able to get all of that information given to us. Now, let's say if we wanted something slightly different. So let's say that instead of finding the sales of each salesman, we wanted to figure out how much money each client actually spent with the branch. Well, instead of using employee ID over here, we can just say client ID, and we'll change this to client ID as well. And now what this will do is it'll tell us how much each client spent. So I'm going to run this, and you'll see down here we get all this information. So client 400 spent $55,000. Client 401 spent $267,000, right? And so we can use aggregation in order to organize the data that we get from using these functions. So I can add up the total sales of each client, and I can group them by client ID. So that's kind of how that works. And so aggregation can be extremely useful, and it's definitely something you want to play around with. So we have this entire database schema over here. And so what you want to do is just kind of try to give yourself little prompts like I'm giving up here, right? So I kind of wrote out these little prompts, and they're kind of like little problems that we need to solve. So we want to be able to figure out like all the different information from the table.
Oh,
In this tutorial, I'm going to talk to you guys about wildcards and the like keyword in SQL. Now, wildcards are basically a way of defining different patterns.
there's another 2 hours left. Let's do it for. I'm going to leave now. 10 more minutes. Where are they? Ten more minutes, Mom. SQL is simple. Watching it at 1.5 times.
That we want to match specific pieces of data to. So this would be a way to kind of like grab data that matches a specific pattern. And I'm gonna show you guys exactly how this works. So I have over here a prompt, and it just says, find any clients who are an LLC. So this is kind of an interesting prompt. Like, let's say that we wanted to query our database and
Okay.
find any clients who were like an LLC. You see over here in the clients table, we actually have one, John Daly
Really
Law LLC. Right? So this is a limited
Taxi.
liability company, and this is kind of what we're looking to find with our search. So I'm gonna show you guys how we can use wildcards in order to find something like this. So I could say select all from client, because I want to grab a client, and now I can use the where keyword. So I want to filter the results, right? Where I'm gonna say client name, and I'm gonna use this keyword called like. And like is a special SQL keyword which we're gonna use with wildcards. Now, we can say like, and then over here we want to write out a little expression or a little statement. So I'm gonna make an open close quotation mark, and we'll put a semicolon over here. And now inside of here, I can use a couple of different special characters. So basically what I can do here is define a pattern, okay? And if the client's name, if the specific client's name matches the pattern that I defined over here, then this condition or this statement here will be true, and we'll end up returning that client. And so,
oh no, I don't like this. What is it called? What is it called? Oh, not this. For crying out loud, I was learning JavaScript until then, like, oh my fucking god, I'm out. G. Goodbye. Hmm. There it is. Regex.
We can basically use wildcards to do a bunch of different stuff. So inside of these quotation marks, we
Yeah, I
can use
had
two
Regex.
special characters. There is this percent sign, and this stands for any number of characters, and then there's this underscore, which stands for one character. And I can use these in order to define certain patterns that can be used by the database in order to find what we need. So over here, I could say like, and I can say percent sign LLC. Basically, what this pattern is saying is if the client's name is like this pattern, then we want to return it. So in other words, if it's any number of characters and then an LLC at the end, then we want to return it. So this percent sign is going to stand for any number of characters. So that means any characters, anything can come before that, but that would mean that the name has to end in LLC. So you'll see over here, John Daly Law LLC has a bunch of characters here, and then the last three characters are LLC. And that's kind of standard. Most limited liability companies will be set up like that. It'll be like company name LLC or John Daly Law LLC. So this wildcard, if there's any company names like that that end with LLC, is going to catch them because it's using this percent sign, which basically means any number of characters can come before this and then LLC. If you're familiar with regular expressions, this is very similar to regular expressions, just a more simplified version. So I'm just going to click run, and you'll see down here we return John Daly LLC, just like that. So that's how we could use these wildcards and this like keyword in order to find something like that. So why don't we try another one? So I have another little prompt here that we can see if we can figure it out. So it says, find any branch suppliers who are in the label.
Who are in the do you guys have I don't know. I don't know. This is cool place. Yeah, it's true. Who are in level business for the time? Select all from what? I still can't. I don't know. Wait, I didn't type this out. Good.
business. Okay, so this look in branch by your name. So, and you'll see there's actually a couple of these that have the word label in them. So if the word label is in the company's name, then we know they probably sell labels. And so what I could do is I could say, use a wildcard to see if the word label shows up anywhere inside of their name. So what I could do is I'm actually gonna come over here and I'm gonna change this up. So basically we're gonna have any number of characters. We're gonna use this percent sign, and then I'll just say label, and then we'll make another one with another percent sign. So actually, why don't we check to see if the word label is actually in there? So it's gonna be percent and then label just like that. So this is gonna be our wildcard. So this will basically match if the supplier name has the word label in it somewhere. So now I'm gonna run this, and you'll see down here we get this company JT Forms and Labels. And so actually I thought there was two of them. Let me see. Okay, yeah, so it looks like I have a typo here. Looks like when I was inserting the data, I spelled labels wrong on this column. So that's going to be why that one's not showing up. But if I'd spelled this correctly, then Stanford Labels.
It's gonna be ending. If I put this here, it will be anywhere before, after, in the middle, you know.
Shown up. So that kind of shows you guys how we do something like that. So why don't we find another one? All right, so this one says find any employee born in.
Well, that is just function. That don't need anything. Wildcards. Octo. Wait. Ooh. Ooh. Ah. Ah. Wait. Ah. Touché. But can I? Can I do like, for example, an integer? Can I do like this? Well, let's see. I suppose. October, September, October.
In October. So this one's kind of interesting. You'll see over here on the employee table, we're actually storing the dates for all the birth dates for all the employees, and they're all structured the same exact way. We have a 4-digit year, a hyphen, and then the 2-digit month. Now October is the 10th month, so let's see if we have any employees. So we have one employee down here. Jim Halpert was born in October. So what we can do is let's see if we can design a wild card that will figure that one out. So over here we can change this to employee, so from employee, and we want to check to see if the birth date is like the wild card. So what we can do is we can actually use this character right here. It's this underscore. So the underscore represents any single character. So the percent sign represented just like any number of random characters, right? It could any number of characters would match it, and the underscore represents one character, and we can use that to our advantage. So we know the way that these dates are formatted, right? It's a 4-digit date, a hyphen, or it's a 4-digit year, a hyphen, and then the 2-digit month. So we can do 1, 2, 3, 4 underscores, a hyphen, and then a 10, and then we can do this percent sign. So what this is going to match, it's going to match with any 4 characters, a hyphen, and then 10. So this should give us all of the birthdays that are in October. So I'm going to run this, and you'll see over here we get Jim Halpert. So it says Jim Halpert, and he is indeed born in October. So you can do this for any month. We can see if there's any employees born in February. And you'll see down here, looks like we have 2 employees born in February, also born in different years. So that kind of gives you an idea of how we could do something like that. Again, we're using these wildcards. All right, so let's try one more. It says find any clients who are schools. So
oh no, it's broken. It is not. I fixed it on the rest. fine. It's fine.
This one's kind of interesting. Basically, we're looking for any clients that might be schools. So what we could do is we could say select all from to look for, but hopefully it should be is two. So underscore. And the whole idea is we want to build these, then we're going to go ahead and return it. And those can actually be really useful with the colors, and we have the underscore. And the whole idea is we want to build these little expressions here, which will be able to match. So like the client name should be able to match.
But it's pretty simple, right? So you wanna know what a regex in JavaScript looks like? So it's hell, like actual hell. What the fuck is this, dude? Like, it's actual hell, dude. Regex in insane.
This expression, and if it does, then we're going to go ahead and return it. And those can actually be really useful when you're just trying to, kind of query something from a database. So imagine that you're building like a searching application, and the user entered in a bunch of search terms. You could use something like this in order to search the database for you. In this tutorial, I'm going to talk to you guys about unions in SQL. Now, a union is basically a special SQL operator which we can use to combine the results of multiple select statements into one. So I might have, 2 or 3 different select statements that I'm using, and if I wanted, I could combine all of them into the same result and get just a big list or a big table back from the database. So I'm going to show you guys how we can do this, and I'm actually going to give us some prompts so we can kind of practice. So over here, I have a prompt that says find a list of employee and branch names. So this is kind of interesting. We can actually use the
find a list of employee and branch names.
Union operator in order to do this. So first thing, why don't we see how we could just grab just the employee names and just the branch names. So if I wanted to just grab the employee names, I could just say select first name, and why don't we just grab the first name from employee, right? So that's pretty easy. I mean, that's as easy as it gets. We're just getting all the first names from the employees. Let's do the same thing for branch name. So I could say select branch name from branch, right? Again, pretty simple. So this over here will give us all the names of the employees. So if I was to just run this,
Oh. Why? Control W? No. Enter. What's this? Ugh. Go back. Ew, dude. That is so ugly. That is very, very ugly. There it is. Wait, I cannot change it? Fuck. What? Ah. No, they actually pissed me off by like, oh, I cannot do it. You need to upgrade the fucking go fuck yourself. It really pissed me off. Fuck me off.
This you'll see.
Union. Fuck me. And select first name. Employee Rick. Oh, why did it change me into a pickle Rick? I thought you were the one that wanted to be a pickle.
See, we get all the names of all the employees, and if I was to run this, we get the names of all the branches. But how can we combine those together into one single statement and then just get a list with all that information in it? Well, I can use the union keywords. Over here, I could just say union. I'm actually going to get rid of the semicolon. So now we have one single SQL query, which is going to ask the relational database management system to return not only the employee first names, but also the branch names in a single column. So I'm going to go ahead and run this, and you'll see down here that we get this big column right here. It just says first name, and then we have all of the names of the employees, but down here we also have the names of the branches. So corporate, Scranton, and Stanford. We have all that information, and it's all combined with the names of the employees. So this is actually pretty cool. And when we're using unions, you can do unions on a bunch of different things. There are a couple rules though. So the first rule is that you have to have the same number of columns that you're getting in each select statement. So in this first select statement, I'm grabbing one column. In the second select statement, I'm grabbing one column. If I was to come up here and also try to grab like last name, now when I run this, we're going to get an error because up here we have two columns and down here we only have one. So that's the first rule. You can't do that. They have to have the same number of columns. They also have to have a similar data type. So first name and branch name, they're both strings, right? So they're both of a similar data type, so we're able to return them in the same result. But if you got two things that were very different data types, then it might not necessarily work out as well. So that is basically how we can do these, and that kind of just shows you guys how we can use the union operator in order to combine the results from multiple statements. If we wanted, we could add in another one too. So I could say like union again, and now we could union all of that with like select client name from clients. Now I'm grabbing not just the names of the employees and the branches, but also the clients. So when we run this now, you can see we're getting this really long list that has all these names. And one thing you might notice is that the column name up here is first name, right? So this is saying that it's first name, when in reality, that's not necessarily what this is. And so over here, you'll see that it's first name because the first select statement, the column that we were grabbing was called first name. So that's why that's showing up as first name. But if you wanted, you could change that. So I could say first name as, and then I can change the name. So I could just say like company names. So now the column name is going to be company names instead of first name. So now this is just like all the different names that we have stored in the company database. So hopefully that kind of makes sense, and that's kind of how we can use unions. I'm going to show you guys a couple other cool ones that we can do. So I'm going to pull up another prompt here. Why don't we take a look? It says, find a list of all clients and branch suppliers as names. So this is actually pretty similar. So we can
Did you fucking...
select client name from client, and then we can also union this with select supplier name from branch supplier. And so now we're going to get a table with all the client names and all of the supplier names. So let's run this, and you'll see over here we get all that. So we have all of the clients, and then we have all of the suppliers. And you'll notice over here on the client table and the branch supplier table, both of these have a branch ID column. So the branch supplier has a branch ID column, and the client has a branch ID column. So what we could do is we could use that. So I could say like select client name, and we could also select branch ID from client, and we could select supplier name and the branch ID from the branch supplier, and that'll give us now not only the client names and the supplier.
Yeah, it feels so slow, dude. When we... It feels so slow when when you fast forward like 135 20% faster, and then you're back to 0. It's gonna sound so slow.
For inserting all of these different students into the database. So you'll see we're inserting these have branch ID. And what that does is it basically just makes it a little bit more readable. So now I know that this branch ID comes from the client table and this branch ID comes from the branch supplier table. You don't have to do that, but in a lot of circumstances, it can be extremely useful. All right, so I want to show you guys one more thing we can do with unions. So I'm going to give us another prompt here, and it basically just
Spend or earn. Ooh. Oi, bruv, can you disappear for a second? Just within workspace sama employee. Employee pengeluaran. Workspace income. Right. Sorry. Good God.
says find a list of all money spent or earned by the company. So this one's kind of interesting. All the money that the company either spends or earns, we want to combine into a single list. So basically, the company earns money through the total sales down here, and the company spends money. So I could just say employees column together. But you can basically just combines the results from a number of unions can be very useful for sort of combining all this data into. In this tutorial, I'm going to talk to you guys.
Anyway, then studying. Can you call this studying? I don't know. Hello. Oh, there's some. What is it called? A long fucking. Hello? 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 Okay. Sorry, there's a long fucking delay here. Say hi to my beautiful, beautiful laptop. Eh, I'm gonna end it now. Goodbye. I'm going to sleep. I'm going to pray subuh first. Let's focus comfortably. Yeah. Dadah. Did I fool you?